Hi everyone, this is Dr. Nak. In this video, we are going to go over the practice midterm exam. This midterm exam will cover sections from 2.5, 2.6, 2.7, 3.5, 3.6, 10.1, and all of Chapter 8. Yikes, I know. But please note that your actual exam is going to look just like this, except I might give you more space to work on. But that's the only difference. All the layout, all the problems are exactly the same, except for the numbers has been changed and function has been changed and maybe the graph has been changed. All right, are we all ready to do this? Let's do it. So for number 1, for the given graph below, answer the following. So there are two parts to it. Part A, compute f of 0, and then part B, evaluate f of -2. All right, so let's first go with f of 0. So this is asking you when x is 0, what is the corresponding y value? Because remember, y equals f of x, right? So when x is 0, I see two y values here. Namely, let me just change the color. Namely, at this point, which is 2.5. And then another point, so if you go down when x is 0, boom, here's another point right here. So this point right here is -6.5-ish. Okay, so I'm just gonna write it as -6.5. So here our answer is going to be 2.5 and -6.5. We're going to do the same thing for f of -2. So this is asking you when x is -2. Where is -2? -1, -2. Now, what's the corresponding y value? So here, again, we're going to have 2 points here. This point, this point. So what is that? This part is when y equals to 1. And the bottom one is y equals to -5. So here our answer is going to be f of -2 equals 1 and -5. Now let's go with part B. Find the domain and a range. Express your answer in interval notation. Now let's first go with the domain. Now the domain is nothing but a set of all x values where the graph is defined. So set of all x values. Okay, so let's take a look at this circle. Now, where is the end of all the x values? Well, it looks like our graph, the smallest x value is at this point right here, which is what, -3. Do you see that okay? And then, let me just draw the line. And from there, let's see. All the graph is defined all the way, all the x values in between here. And then it's going to end right here, which is x equals to, what is that? That's 5, 6, 7. So again, notice that all of the graph fits between x equals to -3 and then x equals to 7. So here, our domain in an interval notation is going to be close bracket -3, comma, close bracket 7. Now, if you have a close bracket, that means that -3 is included and then 7 is included. Now let's go with the range. Now the range is set of all y values where the graph is defined. So let's take the maximum point and a minimum point of the graph. Now to compute the range, you're looking at set of all y values where the graph is defined. So where does the very, very highest point of the circle? I think it's right here, isn't it? So what is the y value there? Y value is 3. Now, where is that? The lowest point on the circle? Well, it looks like it's probably right here would be the lowest. So what is the corresponding y value at this point? Well, the y value is going to be, what is that? -7. So again, look at it. Our graph is all contained between when y equals to -7 all the way up to y equals to 3. So in this case, our answer for the range is going to be close bracket -7, comma, 3, close bracket. All right, let's go with part E. Does the graph defines a function? Explain. So remember that theorem, it says that if the graph fails the vertical line test, then the graph is no longer a function. So in this case, I do believe that this is not a function because look, if I draw a vertical line, like let's just say right here, notice that that line intersects the graph at 2 points, which is this point and then this point. Now, if it is a function, then when you do the vertical line test, that line should intersect with the graph only at 1 point. So in this case, it intersects at 2 points, so therefore it is not a function. So I'm just going to write it as not a function, and then just say that because it fails the vertical line test. Now let's take a look at number 2. Determine whether the given relation is a function. Give the domain and a range for the relation. Okay, so let me just, let's do one thing at a time. So the easiest part will be finding the domain and a range. So remember, the domain is set of all x values. So here, what are the x values? We have -3, -2, -1, 0, 1, 2, and a 2. Right? So now if the values repeats, please only write that number once. Okay, so here our domain is going to be x equals to -3, -2, -1, and then 0, and then 1 and just 2. I know you so want to write 2 and then another 2, but don't do it. Okay, so here it is. Now let's do the same thing for range. Now again, range is set of all y values, right? So what do we got? We have 9, 4, 1, 0, 1, 4, 9. So whatever it repeats, do not write that number twice. Okay, so here our range is going to be y is 9, and then 4 and a 1 and 0, and then another 1 that's already taken care of. This one right here, I already wrote down 1, so I'm not going to write another 1 there. And then 4, well, I already wrote down 4, so I'm not going to write another 4 into the set. And then 9, same thing, I already wrote down 9. So our range is just consists of 4 numbers. Now the next question is this relation a function? Yes or no? Okay, so please note that if the relation is a function, then every x better have exactly one y value. So I just wrote that out. Now let's take a look at this. I'm a very visual person, so I usually draw a picture. Here's my domain, and let's just say this is my range. So the domain values are -3, -2, -1, 0, 1, 2. And then here you're going to have a 9, 4, 1, and a 0. So this is my domain, this is my range. Now, so let's just map it out. So -3, when x is -3, y is 9. And then when x is -2, y is 4. X is -1, y is 1. And when x is 0, it's going to go to 0. So far so good, because look, every x value has exactly one y value. And when x is 1, it's going to go to 1. This is okay because when x is 1, it has exactly one y value, which is 1. Now, the next one is going to be the problem. Let's take a look at x equals to 2. So when x equals to 2, we have two different y values, which is 4 and a 9. So right there tells us that this relation is no longer a function. So let me just draw the picture out. So here, let me just change the color. So this is telling us that 2 is going to go to 4 and 2 is going to go to 9. Okay, so therefore, is this a function? I would say no, because 2 has two y values. All right, now let's take a look at number 3. F of x equals -4x squared minus 5x plus 2. Find the indicated function value. Simplify your answers all the way. All right, so first we want to compute f of -4. So what we need to do is we need to replace our x with -4, and then we're going to compute that value. Okay, so here, let's just do this. I'm going to do this step by step. So this is -4 times -4 squared minus 5 times -4 and then plus 2. Okay, so then this is going to be negative 4 times, now negative 4 squared is negative 4 times the negative 4, right? So that's going to give us positive 16. And then here, negative 5 times the negative 4, so minus 5 times negative 4, that's going to give us plus 20, and then plus 2. So here we're going to have negative 4 times 16, that's negative 64, and then plus 20, and then plus 2. Now, when you add and subtract the numbers, you always have to compute from left to right. Okay, so first add those two together, negative 64 plus 20. And that's negative, what is that, 44? And then plus 2. So what is my final answer? So this is going to be negative 42. So here I'm going to write my answer. F of negative 4 is negative 42. All right, now let's go with f of x plus h. Okay, so I used to have the biggest issue with problems like this when the numbers disappears and everything is a variable. So, okay, let's take one thing at a time. So what we need to do is this. Pretend that x plus h, this quantity, is just like one value. Okay, so now what we're going to do is we're going to replace our function's x's with the quantity x plus h. All right, so let me just do this again step by step. So here we're going to have negative 4 times x plus h squared minus 5 times the x plus h, and then plus 2. All right, now next step, be careful. This portion right here, right, x plus h whole quantity squared, this does not equal to x squared plus h squared, by the way. So remember, exponent indicate repeated multiplication. So in this case, we're going to have to multiply x plus h twice. Okay, so with that said, I can rewrite this as negative 4 times x plus h times another x plus h. All right, now let me just distribute the negative 5 to each term so that way I can drop that the parentheses. So here you're going to have negative 5x minus 5h, and then just jot down plus 2. All right, so next what I'm going to do is this. Let's multiply this out. But remember, we're going to multiply that by the whole negative 4, right? So here you better have negative 4 and I put a bracket around it. Okay, so then if I multiply this out, we're going to have x squared plus xh plus another xh plus h squared. And then let me just drop down minus 5x minus 5h and then plus 2. All right, so next step, let me just I could combine these together, right? 1xh plus 1xh is going to give us 2xh. So here you're going to have negative 4 times x squared. I guess I could put that as a parentheses, bracket, parentheses, I don't care which one you write. But x squared, we're going to have plus 2xh plus h squared. And I'm just going to copy and paste negative 5x minus 5h and then plus 2. So the last step, distribute the negative 4 to each term in a bracket. So then here you're going to have negative 4x squared and then minus 8xh. And then minus 4h squared, and then minus 5x minus 5h, and then plus 2. Now, do we have any like terms here? X squared, xh, h squared, xh? Nope. So guess what? That whole thing is going to be our answer. So therefore, f of x plus h is going to be, I think I'm not going to be able to write the whole thing in that one line, so I'm just going to go like this. Answer goes here. All right, number 4. Let f of x equals negative 3x squared minus 2x plus 1, and g of x equals 8x plus 3. Find f of negative 1 plus g of 2. Okay, so now in order to do this, I like to take one thing at a time. Okay, so first what I'm going to do is I'm going to compute f of negative 1. Then I'm going to compute g of 2. Then at the end, I'm going to add them together. So let's do it. Now, I'm going to work this as a side work. SDWK means side work. Okay, So here, let's first go with f of negative 1. So we have f of negative 1. So I'm going to replace, I'm going to be looking at a function f, and I'm going to replace its x with negative 1. So here you're going to have negative 3 times negative 1 squared minus 2 times negative 1 and then plus 1. All right, so then here you're going to have negative 3 times, now negative 1 squared is positive 1, and then minus 2 times negative 1 is going to give us plus 2 and then plus 1. So this is negative 3 plus 2 plus 1. Now be careful, you're going to add this from left to right, okay? So here, first you do negative 3 plus 2, which is negative 1. And then I'm going to add 1 to that. So f of negative 1 is going to be 0. So here, what we're going to have is we're going to have a 0 and then plus, and then the g of 2, right? So let's do that as a side work. So I'm going to write it over here. Side work for g of 2. Okay, so the g of 2 is going to be 8 times 2 plus 3. So this is 16 plus 3, which is going to be 19. Great, so g of 2 is going to be 19. So 0 plus 19, our answer is going to be just 19. So I'm going to write that here. Part B, f minus g of x and f minus g of 0. So first step first, f minus g of x, that's the shorthand notation for f of x minus the g of x, by the way. All right, so let me just write it like this. I'll write every step out. F minus g of x. So this is f of x minus the g of x. All right, so then here, let's just, what is our f of x? Our f of x is negative 3x squared minus 2x plus 1. And then minus the whole entire g of x. So make sure that you have a parentheses around your g of x. So here you're going to have 8x plus 3. So now what we're going to do is we're going to have to distribute this negative sign to each term to drop that parentheses. So here you're going to have negative 3x squared minus 2x plus 1 minus 8x and then minus 3. So please be careful on that step. All right, now let's combine the like terms. So we have negative 3x squared, and then I could combine negative 2x and then minus 8x. So you're going to have negative 10x. And then I can combine plus 1 minus 3. So that's, what is that, minus 2. All right, so that's gonna be our answer. So right here, this is what I was talking about at the very beginning. I think you might need that, especially if you write big, you might need a little bit more room. So I will make sure to give you all more room to write on this. Okay, so here, let me see, what the heck was I just saying? Oh yeah, yeah, I was about to write this answer. Here we go. Negative 3x squared minus 10x, and then minus 2. Okay, now let's go with second part, f minus g evaluated at 0. Now, there are two ways that you can do this. Now, there is a safe way, and there is kind of safe way. All right, so kind of safe way is this. You already computed f minus g of x. It's right here. Okay, now, so that means that f minus g of 0, all you have to do is replace this x with a 0. So you could see that already the answer is just going to be negative 2, right? Okay, but however, what if you made a tiny mistake by computing this, right? So then if I plugged it in 0 and a wrong answer, do you see that both answers are going to be wrong? Okay, so with that said, I'm going to do this by the safe method. Okay, so the safe method will be this. As a side work, I'm going to compute f of 0 and g of 0. And then I'm going to subtract those. Okay, so here, let me just write every step out. F minus g of 0 is f of 0 minus the g of 0. Okay, now as a side work, f of 0, so that's going to be negative 3 times 0 squared minus 2 times 0 plus 1, so that's just going to be 1. right? So this portion's just going to be 1, and then you're going to have a minus. Oh no, I'm running out of room. Now let's do another side work. G of 0. So the G of 0 is going to be 8 times 0 plus 3. So that's going to be 3. So here you're going to have 1 minus 3. And as we guessed, our answer is going to be negative 2. So I'm going to write that answer here. So again, if you're confident, 100% confident that you computed f minus g of x correctly, then just straight up just plug it in 0 in place of x, and you can see already that our answer is going to match up as negative 2. All right, let's look at the next one. F times g of x and evaluate f times g of negative 1. So here again, fg of x, that's a shorthand notation for f of x times the g of x. Okay, so let me just start out. Fg of x means it's just f of x times the g of x. Okay, so then let's just do this. So here you're going to have f of x, which is negative 3x squared minus 2x and then plus 1, and multiplying here by g of x, which is 8x plus 3. All right, we can do this. So we're going to multiply this out. So first what I'm going to do is take negative 3x squared and distribute that to 8x, and then 3. And next I'm going to take minus 2x and distribute that to each term of g of x, and then distribute the 1 to each term. Okay, so here let's just do this step by step. So here first of all, I'm going to multiply negative 3x squared times 8x. So what is that? Negative 24x cubed. And then you're going to have, so right now I just multiply this together. Now I'm going to multiply these two. So you got a negative 3x squared times 3. So here our sign's going to be minus. And then here you're going to have 9x squared. All right, and the next one, I'm going to have minus 2x times 8x. So what is that? 16x squared. And then negative 2x times 3, so the sign's going to be minus 6x. And then distribute the 1 in, so that's just going to be plus 8x and then plus 3. Okay, now let's combine the like terms. So x cubed, that's only one term of x cubed, right? You got a negative 24x cubed. Now let's go with x squared, so I can combine negative 9x squared minus the 16x squared, so that's minus 25 x squared, and then I can combine the x's together. You have a negative 6x plus 8x, so that's going to give us plus 2x, and then the constant term is just going to be plus 3. Okay, so that's going to be our answer. So again, the answer box looks really, really small, so I'm just going to box this, and then I'll just put an arrow right here. All right, so now let's go with f times g of negative 1. So again, if you're 100% sure that you computed this end result correctly, then just feel free to plug it in negative 1 in place of x, and then boom, there's your answer. But like I said on the previous example, what if you made a tiny mistake, right? I mean, this problem, it's easily to make like maybe sign mistakes or something like that. So if I were you, I will use the safe method. Okay, so the safe method would be this. First, I'm going to evaluate f. Here, I'll just write everything out, sorry. So here you're going to have fg of negative 1. So that's same thing as f of negative 1 times the g of negative 1, right? So again, I'm going to work each f of negative 1 and g of negative 1 as a side work. Okay, so here, let's just go with, first, let's go with side work. F of negative 1. Now, f of negative 1 is going to be, I think we computed that in part A, no? But well, let's just do it again. So you got a negative 3 times negative 1 squared minus 2 times negative 1 plus 1. So that's going to give us negative 3 times 1 plus 2 plus 1. So here you're going to have negative 1 plus 1, which is going to be 0. But we already knew that because we computed it up here. But what the heck, right? So here I'm going to write this as 0 and then times. Now let's do the side work for g of negative 1. Side work. G of negative 1. So here you're going to have 8 times negative 1 and then plus 3. So that's negative 8 plus 3. So what the heck is that? Negative 5. So here you're going to have 0 times negative 5. Well, 0 times anything is 0. So I guess I really didn't need to compute g of negative 1. But you know what? I did it anyways. So there. So here our answer is going to be 0. So here I'm going to write my answer here as f times g of negative 1 is 0. All right, now let's take a look at number 5. Let f of x equals square root of x plus 2 and g of x equals 4x minus 1. Find the following, simplify your answers all the way. All right, this is going to be a composition problems now. So again, please note that this does not mean f times g of x. This reads as f of g of x. All right, so let's take a look. So I'm going to rewrite every single step. So this is f of g of x, right? So this is same thing as f of, well, what's g of x, which is 4x minus 1. Now, next step is the tricky part, right? So pretend that 4x minus 1 is one quantity, all right? And then, so this is telling us that look at function f and replaces x with what's in the parentheses. So here, what we need to write is this. On the next step, you're going to have square root of 4x minus 1, because remember, I'm just circling that, and then I'm replacing this x with what's in the parentheses, right? And then you're going to add plus 2. All right, so this is going to be just square root of 4x, and then you have a minus 1 plus 2, so that's going to be plus 1. All right, and that's going to be the answer. By the way, please note this. This does not equal to the square root of 4x plus the square root of 1, by the way. So be careful right there. I used to do that all the time when I was a student. So I don't want you to do that. All right, so here answer is square root of 4x plus 1. Okay, now let's go with f of g of 2. So again, we can do this in two different ways. Kind of a safe method or totally the safe method. So the kind of safe method is, again, if you're 100% sure that you computed f of g of x correctly, then all you have to do is f of g of 2, so replace this x with the 2 and then just compute it. But what if, you made a mistake or I made a mistake here, right? So the safe way would be this. I'm just going to do the safe way. So the safe way is this. So this means that f of g of 2. Now, as a side work, first compute g of 2. Okay, so I'm going to bring it over here. Side work. G of 2, so that's going to be 4 times 2 and then minus 1. So what is that? 8 minus 1, which is 7. So the next step, this is going to be f of 7. Right? So now all we have to do is look at function f, which is square root of x plus 2, and then replace that x with a 7. So here you're going to have a square root of 7 plus 2, which is going to be square root of 9. You have to simplify all the way, so our answer is going to be 3. So let me just write that there. All right, next we're going to compute g of f of x. So we got this. So ready? You're going to go g of f of x. That's the first step that you should write. And then here you're going to have a g of, now what was my f of x? Square root of x plus 2. Now the next step is this. This is telling us that look at function g and replaces x with what's in the parentheses. So here, let me just color code it. So you need to replace the x that belongs in g of x, which is this guy, with the square root of x plus 2. So here, our next step is going to be 4 times the square root of x plus 2, and then minus 1. All right, and that is the simplest you can go. Okay, so do not distribute the 4 into the radicals or something like that. Leave it the way it is. So here our answer is going to be 4 times the square root of x plus 2 and then minus 1. Okay, now let's go with g of f of negative 2. So again, you know, if you're 100% sure, then just replace this with the negative 2. So you have a square root of negative 2 plus 2. So square root of 0, which is 0. 4 times 0 is 0 minus 1. So the answer should be minus 1 if you did it correctly. Okay, but anyways, I'm going to do this the safe way. Okay, so here I'm going to have g of f of negative 2. So let me just take f of negative 2 and then compute that as a side work. So f of negative 2, so that's going to be the square root of negative 2 plus 2, which is square root of 0 is 0. All right, so now this problem boils down to g of 0. Now, let's just look at function g replaces x with the 0. Then here you're going to have 4 times 0 and then minus 1. So this is 0 minus 1, which is negative 1. So that's going to be our answer. Moving right along, let's look at number 6. Find the equation for f inverse of x. Verify that your equation is correct by showing that f of f inverse of x equals to x and f inverse of f of x equals to x. You must show all of your work in organized manner to receive any credit. So first, let's try to get our f inverse of x. So step number 1, replace f of x with a y. So here you're going to have y equals 2 over x plus 5. Now next step, interchange the role of x and a y. So here you're going to have to rewrite x equals 2 over y plus 5. Okay, now our next job is this. Solve for y. Okay, that new y becomes your f inverse of x. Okay, so let's do this. So how we're gonna do this is I'm going to multiply both sides by the least common denominator, which is y plus 5. Okay, so here I'm gonna multiply here by y plus 5 and then multiply this whole thing by y plus 5. Okay, now if I do that, notice that I can kill these two, right? So then here I'm just left with, let me just swap the ordering, x times y plus 5 equals to 2, right? So now remember what you're doing. You're trying to solve for y. So from here, you can divide it by x if you like. So here, if I divide it by x, then what are we going to get? Let me just go over here. So you're going to have y plus 5 equals to 2 over x. And then subtract 5 from both sides. Then you're going to have y equals 2 over x minus 5. Okay, so therefore this new y becomes your f inverse of x. So here f inverse of x is 2 over x and then minus 5. Okay, now the verification. So we need to check f of f inverse of x, and then we're hoping that that's going to equal to x, and then also f inverse of f of x, we're hoping that that's going to equal to x. Okay, so let's check. All right, so we're going to have f of f inverse of x. So here you're going to have f of 2 over x and then minus 5, right? So now what we need to do is look at function f, right? And then replace its x with what's in the parentheses. Are you all with me? So here you need to replace this x with 2 over x minus 5. So here we're going to have 2 over x minus 5 and then plus 5. All right, so then what are we going to get? So this is the same thing as 2 over, I can drop that parentheses, 2 over x minus 5 plus 5. So looking good. So this is 2 over negative 5 plus 5 becomes a 0. So you're going to have 2 over x. Now that's same thing as 2 over 1 divided by 2 over x, isn't it? So how do you divide the fractions? You multiply the reciprocal of the second fraction, right? So this is same thing as 2 over 1 times by x over 2. So then 2 is going to cancel each other out. So you're just left with x over 1, which is just x. Yes. So f of f inverse of x equals to x. We're in good shape. All right, now we're going to go the other way around. Okay, do not panic. We can do this. So we got f inverse of f of x. So that's f inverse of, what the heck is my f of x again? Oh, 2 over x plus 5. Okay, so now what we need to do is look at our f inverse of x, right? Now we're going to have to replace this x with what's in the parentheses here, which is 2 over x plus 5. So I'm going to replace this with 2 over x plus 5. Okay, so then let me just write every step out. So this is 2 over, do not panic, 2 over x plus 5, and then minus 5. Okay, we can do this. Okay, I know it looks so ugly, I know, but you must become one with fractions, people. All right, so let's do this. So this is same thing as 2 over 1 and divided by 2 over x plus 5, isn't it? And then minus 5. So this is same thing as 2 over 1 times, I should put parentheses here, x plus 5, and then over 2, and then minus 5. So then kill the 2, kill the 2. And so what do we have left? Let me just go over here. So that's same thing as x plus 5 over 1 and then minus 5. Well, x plus 5 over 1 is just x plus 5 and then minus 5. Boom. That's going to equal to x. All right. So guess what? It wasn't as bad as you thought, was it? Okay. So therefore, we computed our f inverse of x, which is 2 over x minus 5, correctly. All right, let's take a look at number 7. Find a solution set for the equation. So we have absolute value of 5x minus 3, and then minus 2 equals to 26. So step number 1, isolate that absolute value. So here what I'm going to do is add 2 to both sides. Then here you're going to have an absolute of 5x minus 3 equals to 28. Now, in order for us to drop that absolute value, remember you're going to have a positive side and a negative side, right? So be careful here. So the positive side will be this. 5x minus 3 equals to 28. And then the negative side is going to be 5x minus 3 equals to negative 28. So don't forget this portion. Okay, and then we just solve it separately. So from here, let's just work on the left-hand side. I'm going to add plus 3 to this. Then you're going to have 5x equals 31. And then dividing by 5. So it looks like our x is going to be 31 over 5. Okay, and the negative side, we're going to do the same thing. Let's just add 3 to both sides. Then here, what we're going to get is 5x equals negative 25. And then dividing by 5. And here we're going to have x equals to negative 5. So we have a solution set is 31 over 5, comma, negative 5. And how do you know that if your answers are correct? All you have to do is just check your solutions. Plug it in 31 over 5 in place of x, and then make sure that when you drop that absolute value, it's going to equal to 26, and then do the same thing for the negative 5. By the way, I already checked. They're both legit answers. All right, now let's do number 8. Find a solution set for the equation. We are given 2 absolute values here. So in order for us to drop that absolute value, we're going to have, again, a positive side and the negative side. Now, it does not matter which expression that you're going to take to attach that positive or negative, but let me just do it this way. So I'm just going to keep 3x over 4 plus 2. Now that's going to equal to the positive side of x over 3 and then plus 2. Of course, you don't need to write that positive side and the plus sign, but let me just do it so you don't forget. And then another one is 3x over 4 plus 2 equals to the negative side. So you're going to have a negative x over 3 and then plus 2. All right, so what we need to do is we need to solve 2 equations here. So let me just do this. So let me just rewrite. 3x over 4 plus 2 equals to x over 3 plus 2. Now, no one likes to deal with fractions, I believe. So the trick is this: multiply by the LCD, least common denominator of all the fractions that you see. So here, denominator is 4, denominator on the 2 is 1, denominator here is 3, denominator on the 2 is 1. So what's the least common denominator? 4 and a 3 and a 1. That will be 12. So here, what I'm going to do is I'm going to multiply both sides by 12. So 12 is same thing as 12 over 1. Don't worry, I'm going to do this step by step, okay? Now what we need to do is we need to distribute this 12 to each term. And then you'll notice that the next step after you simplify, the fraction will disappear. So here, let me just do it this way. So this is same thing as 12 over 1 times the 3x over 4 plus 12 over 1 times 2. But 2 is same thing as 2 over 1. But let me just keep it as a 2. And that's going to equal to, now I'm going to distribute 12 over 1 times it by x over 3. And then plus 12 over 1 times it by 2. So now let's just keep doing this. Now 4 goes into 4 once, into 12 3 times. So what do we have left? 3 times 3x, so that's going to be 9x. And then you're going to have 12 times 2, so that's plus 24. And that's going to equal to, all right, now I can reduce the 3 goes into 3 once, into 12 4 times. So what we're left with is 4x, and then plus 12 times 2, which is 24. Boom, look at it. Beautiful, no more fractions. Okay, now from here, just solve it like how you usually do. So I'm going to subtract by 24 on both sides. Then what do we get? I'm going to have 9x equals to 4x and then plus 0. So I'm just going to leave it as that. Now, don't panic. I know this looks really strange, but you can combine the 9x and then by subtracting 4x onto the left-hand side. So here, I'm going to subtract 4x. Then here, you're going to have, how many x's are we going to have? 5x equals to 0. Okay, and then how do you solve for x? Divided by 5. So here you're going to have x equals to 0 over 5, which is going to be just 0. All right, so this is one answer. Okay, now let's go to the negative side. Okay, so we're going to do the same thing. So you're going to have 3x over 4 plus 2. Now, step 1, distribute that negative sign in. You're going to have negative x over 3 and then minus 2. Next step, multiply by the LCD, which is just 12. Okay, then we're going to distribute, and cancel what we can to simplify. So here, 12 over 1 times 3x over 4, and then plus 12 over 1 times 2 equals 12 over 1 times split by, you're going to have a negative x over 3, and then minus 12 times 2. I'll just put 12 over 1, and then multiplying here by 2. Okay, so now canceling time. 4 goes into 4 once, into 12 3 times. So what's left is just 9x, and then plus 24 equals, now here 3 goes into 3 once, into 12 4 times. So here what we have left is just negative 4x and then minus the 24. All right, so now let's just solve it like usual. So next step, I'm going to subtract 24. Then what do we get? We're going to have 9x equals negative 4x and then minus, what is that, 48? Okay, now, oh my gosh, this is supposed to be an x right here, sorry. Okay, and then let me just bring the 4x on the left-hand side by adding it. So I'm going to go plus 4x, plus 4x. All right, so then what do we get? We're going to have 13x equals to negative 48. So now dividing by 13, both sides, then it looks like we're going to have negative 48 x equals, sorry, negative 48 over 13, which I cannot reduce that any further, so I'm just going to box that for the answer. So it looks like therefore, I don't know if I ever used this 3 dot. If I use this 3 dot, this means therefore in a math class, by the way. So therefore, our solution set is 0 and negative 48 over 13. All right, so that's gonna be our final answer. All right, number 9, solve, write your solution in interval notation. If there's no solution, state so. Okay, so let's take a look at this. We have an absolute value of 5x plus 3 being less than or equal to negative 10. Okay, so first let's think about this. The output of the absolute value, right, is always going to be positive. Do you agree? Okay, so x can be negative number, of course, but if you're going to compute and put an absolute value bar around it, this side is always going to be positive. But look at it. So this statement is telling us this. Some positive number is less than or equal to the negative 10. Could that ever happen? I don't think so, because negative 10 is a negative number. So it's smaller than a positive number. So this inequality is impossible because this is telling us the positive number is less than a negative 10. Okay, so in this case, our answer is no solution. So how do I explain this? So this is impossible. And my answer is going to be just no solution. And in a math class, no solution sign is usually circle with the slash or curly bracket with nothing in it, but you can just spell it out, no solutions. I don't mind. All right, so that's that. Okay, so now let's look at number 10. Solve, write your solution set in interval notation. If there's no solution, state so. Okay, we got this. So first, again, we're dealing with the absolute value. So when you drop that absolute value, again, we're going to have a positive side and a negative side. But here we're giving an inequality, whereas the previous examples that we did, it was an equation. So, but anyways, let's just do this. Now, when you drop that absolute value sign, your positive side, you keep your inequality. Now, if you're going to take the negative side of 6, you're going to have to switch your inequality. So here we're going to have 2 minus 3x over 4. Now let's take the positive 6. So you're going to have, this is greater than 6. All right. Or you're going to have 2 minus 3x over 4. Now let's take the negative side of 6, which is negative 6. Now in this case, your inequality is going to swap. Okay. So that's one of the properties that we've learned. Now from here, many ways that you can do, but how about this? How about let's just subtract 2. Let's just work on this inequality first. Then here you're going to have negative 3x over 4 is greater than, what is that, 4? Now I need to get rid of that negative 3/4 because I just want to solve for x. So the trick is to multiply by the reciprocal of negative 3 over 4, which is negative 4/3. So here I'm going to multiply here by negative 4/3. Now, that means that I'm going to multiply here by negative 4/3. Now, do you remember what's going to happen if you multiply by the negative number? So in this case, your inequality sign is going to switch because you're trying to solve for x and you have to multiply by a negative number. So here you're just going to have x equals negative 16 over 3. I don't think I could simplify that anymore, so I'm just going to keep it as that. Why in the heck did I draw that inequality so big? Whatever. I was trying to stress it out because if you multiply the negative number, you better switch that inequality sign. All right, so the next one, let's just do the same thing. So I'm going to subtract 2. Then you're going to have negative 3x over 4 is less than negative 8. So now, again, we're going to multiply by a negative number. When you multiply by a negative number, next step, you better swap your inequality sign. Okay, so then here you're going to have x is greater than, what is that? 32 over 3. Looking good, but look at the instruction. It says write your solution in an interval notation. So now let's just try to translate this in an interval notation. So again, I'm a very visual person, so I usually like to draw myself a number line when I have to do the interval notation. So let me just jot down the key points, negative 16 over 3, and then positive 32 over 3. Okay, so now what we're looking at is, let me just translate this portion. X is strictly less than negative 16 over 3. So it's strictly less than, so which way do we need to shade? You're right, left-hand side. Okay, so be careful here. You can put an open circle around it if you like and then shade it. Or another way to do it is you can replace that open circle with the open parentheses like this. All right, so whichever you want to do is okay. All right, and the next one is x is strictly greater than 32 over 3. So here's my 32 over 3. X is strictly greater than. So which way do we shade? The right-hand side, right? So here, again, you can keep it as an open circle and then shade, or you can have the open parentheses and shade. All right, so now from here, I think it's easier for me to write the interval notation. So remember, this whole tail end is going to keep going to negative infinity. This tail end is going to go to positive infinity. So where do we shade? Well, we shade it from negative infinity to negative 16 over 3 and 32 over 3 all the way to positive infinity. So here, my answer is going to be negative infinity, comma, negative 16 over 3, and then union, here you're going to have 32 over 3, comma, to positive infinity. Now the union sign means or, okay? And then if you have it the other way around, if you have this upside down U, this means and. So maybe I should write that down, huh? This U means or. And then if you have the upside down U, then this is and. Anyways, so that is going to be our answer. Moving right along, so now let's go with 11. Solve the linear inequality and graph the solution set. Okay, so in this case, we're asked to graph the solution set now. I did not ask you to write in an interval notation. Okay, so let's take a look. So here we're given negative 4 is less than or equal to x over 3 minus 4, which is strictly less than negative 2. So first, in order for us to solve for x, first I need to get rid of this negative 4. So how do I do that? Is by, you're right, add 4 to this. Now if you're going to add 4 in the middle term, you better be fair and add 4 to all the terms. Okay, now if I do that, then what do we get? You have a negative 4 plus 4, you're going to have a 0 less than or equal to x over 3, and then strictly less than positive 2, right? And then I want to solve for x, so what we need to do is I need to get rid of this bottom 3. So here you can think of this as the same thing as 1/3 times the x. So what we need to do is we need to multiply this quantity by 3. So if I multiply by 3, then do you see that this 3 and then this 3 is going to cancel each other out. And then you're able to just solve for x. So that's exactly what we're going to do. So here, I'm going to multiply this by, I'm running out of room, 3 over 1. Okay, so I'll just write 3 over 1. So that means that I better do the same thing on the left-hand side and then also on the right-hand side. So then here, you're going to have a 3 times 0, which is 0. Less than or equal to, now notice that our 3 is going to cancel out, so you're just left with x, and then strictly less than 6. Okay, so now we need to graph the solution set. Okay, so all right, so pretend that this is 0 and this is 6. So x is sandwiched between 0 and a 6, but in this case, x is greater or equal to 0. So in this case, if you're going to use the circle stuff, then you better have a closed dot. Now, if you want to use the parentheses or bracket, this is equivalent to bracket. All right, and then on the 6, let's just take a look at 6. So here, this reads as x is greater or equal to 0. So that's why x is greater or equal to 0. So I'm going to be shading this side. And then at the same time, x has to be strictly less than 6. So again, if you're going to use the circle one, you got to have an open circle, and then x is strictly less than 6. So again, you're going to be shading between 0 and a 6. Now, if you're going to use the interval here, then here you're going to have an open parentheses, and you just basically shade inside of that. Now, number 12, solve the compound inequality, graph the solution set. So be careful what the question's asking, graph the solution set, right? So here we have 4x plus 3 is greater than negative 6, and 3x minus 2 is less than 7. So what we need to do is we need to solve this separately, and then we have to keep in mind the word and. So and means you take the overlapping part from the two inequalities, solving for the two inequalities. So here, let's just take a look at this one. So if I want to solve for x, then I need to subtract by 3. So here you're going to have 4x is greater than negative 9. So then dividing by 4, positive 4. So your inequality sign stays the same. So here you're going to have x is greater than negative 9 over 4. Okay, and then don't forget to drop that word and we're gonna do the same thing here. So I'm gonna be adding 2 to both sides. Then you're gonna have, what are we gonna have? 3x is less than 9. So then dividing by a positive 3, your inequality sign stays the same. So here you're gonna have a x is less than 3. All right, so this is the compound inequalities that we get. Now, since the word in between is and, we're going to graph each of the inequalities separately. Then we're going to take the overlapping part of those two intervals. Okay, so if it doesn't overlap, then you just take all of them, wherever you shaded. So let's do this. So here, let me just put the number line. So you got negative is smaller than positive, so negative should be on the left hand side of 3. And let's just pretend that's 3. All right, so this is telling us that x is strictly greater than negative 9/4. So here, if you're gonna use the circle deal, then you're gonna have an open circle, and x is greater than negative 9 over 4, so it's gonna keep going towards positive infinity. Now let's take a look at this one. X is less than 3, strictly less. So that means that, I'll just change the color. So here you're also gonna have an open circle, so x is strictly less. Okay, so now remember, since the word is and, we only take the overlapping part. Okay, so please do not leave your answer like that. Please, your final answer should only be where the two intervals are overlapping. So your answer should look something like this, open, open, and then you just shade in between. Okay, so this is the final answer. All right, so let's go into number 13. Solve the compound inequality, graph the solution set. Okay, so we have 3x minus 4 is less than or equal to negative 10, or 6x plus 5 is greater or equal to 12. Now, please note this word or. So or, if you're doing this problem, then if it's or, you take all the shaded regions all together. And remember, if it's and, you take the overlapping part. But anyways, let's just solve this separately. So first, I'm going to add 4 to the first inequalities. And then here you're going to have 3x is less than or equal to, what is that, negative 6. And then dividing by 3. Then here you're going to have x is less than or equal to negative 2. Is that right? All right. And then let me just do the other side. So now here I'm going to subtract 5. Then you're going to have, so let me just jot down this word or. And then here you're going to have 6x is greater or equal to positive 7. And then dividing by 6. Then looks like we're going to have x is greater or equal to 7 over 6. Okay, so now let me just jot down here as negative 2. and then 7 over 6. Okay, so the first one says x is less than or equal to negative 2. So here I'm going to have closed dot, or you can have again closed bracket going this way. X is less than or equal to negative 2. So I'm going to shade this. All right, and the next one, it says x better be greater or equal to 7 over 6. So here you're going to have another closed dot, or if you want to use the parentheses way, then close bracket, and then you're going to shade this region here. Now, if it's the word is or, you just leave your answer as is. Okay, and then again, if it's and, you can only take the overlapping part. But anyway, so that should be our answer. Okay, so let's take a look at number 14. It says rewrite the expression with a positive rational exponent. By the way, rational means fraction. Okay, and it says simplify. If the fractional exponents appear after simplifying, write the answer in radical notation. Assume that all variables represent positive numbers. So anyway, so let's just take a look at this. Okay, so again, rational exponent means the fractional exponent. Okay, so what we're going to do is first, let's take a look at this problem here. We have quantity negative 27 x to the 1/2. Raise it to the 2/3 power. Right, so in this case, we're going to be applying, I'm going to work this step by step, okay? So remember this property here. Let me just write this out in a different color. So remember that if I have a b to the n, that's a to the n times the b to the n. Okay, so pretend that our n is 2/3, and then our a is negative 27, and b is x to the 1/2. Okay, so I'm going to split that up. So this is same thing as negative 27 to the 2/3 times x to the 1/2 to the 2/3 power. Okay, so now let's take a look at the negative 27 to the 2/3. So remember, this is how I remembered when I was a student, you know, because if I had a fractional exponent, I didn't know which one became the power on the expression and which one became the root, you know, like cube root, square root. So this is how I remembered. Root grows on the bottom, right? So bottom is the root, and then top is the power. So that's how I remember that. But you know what? Just remember however you want. Okay, so anyway, so this is same thing as this. So this is exactly the same thing as the cube root of negative 27, whole thing to the second power. All right, and the next one is this. Now I'm going to use another property, prop 1, prop 2 is this. If I have x to the m to the n, what do I do with those exponents? You multiply them. So you're going to have x to the m times n. Okay, so what we're going to do is we're going to use that property and multiply 1/2 and 2/3. So what do we get? X to the, here I'll just write every step out, 1/2 times the 2/3. So then here, let me just go with this. Now, cube root of negative 27. So you can think of it like this. What times what is going to give us negative 27? Isn't that negative 3? Right? So cube root of negative 27, this portion is just going to be negative 3 to the second power. So if you don't get that, you can just break it down in a prime tree. So remember, you go 27, what times what is going to give us 27? 3 times 9, and then 3 times 3. So this is 3 cubed, right? So therefore, the cube root of 27 is cube root of 3 to the 3rd, which is going to give us a 3. However, we are given the cube root of negative 27. So I'm just going to toss the negative number in front of 3. Okay, and then here you're going to have x to the, well, what are we going to have? 1/3. Okay, so the next step, this is same thing as positive 9, and then x to the 1/3. Now, the instruction says that after you have the rational exponents appearing, write the answer in radical notation. So here I can still make simplify x to the 1/3 in terms of a radical notation, which will be cube root of x. So here you're going to have 9 times the cube root of x. So x to the first power, but we usually don't write that first power. So here our answer is going to be 9 times the cube root of x. Now, number 15 is pretty much the same thing. Okay, so use the rational exponents to simplify the expression. If the rational exponents appear after simplifying, write the answer in radical notation. Okay, so there are so many ways that you can do this. So step number 1, this is what I usually do. I just look inside of the radical and see if I can simplify something. Well, it doesn't look like it, because if this is 12m and then if this is 7m, then I can simplify it, but the variables are different here. So I'm just gonna have to attack the problem as is. So here, so many ways that you can do. So step number 1, you can do it this way. So if you want to, remember this property, a over b to the n is a to the n over the b to the n, right? So I'm just gonna leave the fourth root alone for now. And I'm going to use that property that I just wrote down. So this is 12m to the third over 7n to the third. Whole thing is going to sit inside of the fourth root. Now, I'm going to use this property now. So again, ab to the n is a to the n times the b to the n. So again, I'm just going to keep that fourth root alone. And I'm going to use that second property that I just wrote down for 12m whole thing to the third power. So this is going to be 12 cubed and then m cubed and then whole thing over 7 cubed times by n cubed and all in the square root. Okay, so now let me just bring it over here and write this as fourth root. Let's just leave the fourth root alone. And then we're going to have 12 cubed, which is 12 times 12 times 12. What the heck is that? I'm so tired right now. It's 1728, I think. 1728. And then we're going to have m cubed, whole thing over 7 to the third power. 7 times 7 times 7, that's 343. N cubed. Okay. And I don't think I can simplify that any further, so I'm just going to leave that as my answer. So notice that I kept the fourth root because the question said write the answer in radical notation, right, at the end. So guess what? This craziness is going to be our answer. So let me just write it over here. Fourth root, 1728 m cubed, and then whole thing over 343n cubed. All right, number 16, add or subtract, simplify your answer all the way. Okay, so we're given 2 times the fourth root of x to the fifth, y to the third, minus 6x times fourth root of xy cubed. All right, so let's take one thing at a time. Okay, so the key is this. Let's just simplify the radical. So here, I'm going to start out with this. 2 times the fourth root. So you're given x to the fifth, y to the third, right? So you want to break the x to the fifth into a perfect fourth power. So what is the biggest number before 5 that is divisible by 4? That's a 4, isn't it? So here you're going to have x to the fourth. And then in order to make it up into a x to the fifth, you need another x, right? And then what about y cubed? Well, notice that 3 is less than 4, right? So there is no way in heck that y to the third can become a perfect fourth power. So just leave the y to the third alone. All right, and then here you're going to have a minus 6x times the fourth root. Now, x is same thing as x to the first, which is 1 is less than 4. And there's no way in heck that x can become a perfect fourth power. So I'm just going to leave the x alone. And same thing for the y cubed. Okay, so now let me just circle the perfect power. So this guy is perfect. And then other guys are so not perfect. So now what's going to happen is this. You have a fourth root of x to the fourth. So that's same thing as, I don't know which way you do this. This is same thing as x to the fourth to the 1/4 power. So what's going to happen next is this. This only x gets to go outside of the radical. So here you're going to have 2 times x. And then you're going to have a fourth root of xy cubed. And then minus 6x times the fourth root of xy cubed. So far so good. Now if you didn't catch that, put it this way. So let me just note here. If I have a fourth root of x to the fourth times x times y cubed, this is same thing as fourth root of x to the fourth times fourth root of xy cubed, by the way. And then since fourth root is same thing as 1/4 power, so this is same thing as x to the fourth to the 1/4, multiplying here by the fourth root of xy cubed. So notice that these two, 4 and 1/4, is going to cancel each other out. So do you see that here you're going to have x times the fourth root of xy cubed. And that's exactly what happened here. All right, but anyway, so now let's take a look at this. Do we have a like term? Yes, we do. We have fourth root of xy cubed. They're like terms. I can combine these two. So what do we have? We have 2x minus the 6x. So if I'm going to write every step out, so this is same thing as 2x and then minus the 6x. And then here you're going to have a fourth root of xy cubed. So just think of it in this way. You basically just factored out fourth root of xy cubed from that expression. That's all you did. So here 2x minus 6x is negative 4x, and then you're going to have a fourth root of xy cubed, and it looks like that's going to be our answer. All right, next one. Rationalize that denominator. Okay, so here's the trick. If you want to rationalize the denominator means that you don't want to see a radical on the bottom of the fractions anymore. So what's the trick? Trick is to multiply the top and bottom by the conjugate of the denominator. So the conjugate of square root of 5 plus 2 is, square root of 2 is square root of 5 minus the square root of 2. So that's just the sign in the middle is going to change. So here's the trick. Multiply this guy by square root of 5 minus square root of 2. Make sure to put a parentheses on each one. Negative 5 minus the square root of 2. Now what we need to do is we're going to FOIL it. We're going to multiply the top, and then let's multiply the bottom separately. So first what I'm going to do is I'm going to FOIL the numerator here. Okay, so don't worry, I'm going to write every step out. So this is same thing as the first term, 4 root 2 times the root 5. And then minus 4 root 2 times the root 2. And then plus 2 root 5 times root 5, and then minus 2 root 5 and then root 2. Okay, so I just FOILed the top and then whole thing over. Now we FOIL the bottom. So here you're going to have square root of 5 times the square root of 5. And you'll see that inner term and the outer term is going to cancel each other out. But like I said, I'm going to do this step by step. So you're going to have a minus square root of 5 times the square root of 2, and then plus square root of 2 times the square root of 5, and then minus square root of 2 times square root of 2. Okay, so now let's go from here. So here, since we're given the two square roots together, I could multiply the radicand together. So this portion is going to become 4 times the square root of 10. All right, and then this portion here, square root of 2 times square root of 2, do you remember what that's going to become? That's going to become 2. Okay, so here I'm going to have minus 4 times 2. And then same thing here. Square root of 5 times square root of 5. This is going to give us a 5 back. So here you're going to have plus 2 times 5. And then minus 2 times the square root of 10. Okay, and then whole thing over. So now again, root 5 times root 5 just becomes 5. And then notice that inner term, outer term is going to cancel each other out because they're both negative square root of 10 and the other one's positive square root of 10. And then this guy, let me just jot down the minus sign. And then root 2 times root 2, that's going to give us a 2 back. Okay, almost there. So now I think we can combine 4 root 10 and then minus 2 root 10. So what is that? Just a positive 2 root 10. And then minus 8 and then plus 10 all over 3. So it looks like this is going to be 2 root 10 and then plus 2 all over 3. And the answer box went on to the next page, so I'll make sure to fix that. But anyway, so this is going to be our final answer. All right, so now let's look at number 18. Solve, check your proposed solutions. Make sure to write your answer in a solution set. Okay, so ready to do this. So first you're given cube root of 6x plus 2 and then minus 4 equals to 0. So key is isolate that radical on one side, right? So here, what I would do is I am going to add 4 to both sides. Then here you're going to have cube root of 6x plus 2 equals to positive 4. Okay, now in order for us to solve for x, I need to get rid of that cube root. So do you all remember who's going to kill that cube root? Power of 3. So here I'm going to raise both this side by 3. Well, whatever I'm going to do that to the left side, I better do the same thing on the right hand side of the equation. So now here you're going to have a cube root and power of 3 is going to cancel each other out. So you're going to have 6x plus 2 equals 4 times 4 times 4, which is 64. Okay, now let's solve for x from here. So I'm going to subtract 2. You got 6x equals to, what is that, 62. And dividing by 6, we're going to have x equals, make sure to reduce your answers all the way. So I think 2 is going to go in. So 2 goes into 6 3 times. And then 2 goes into 62 31 times. So it looks like this is going to be 31 over 3. So here our answer, the solution set, is nothing but this little curly bracket. That's called a solution set. So we say that solution set is 31 over 3. That's how to write your answer. Now it says to check. If you're confident that you did it right, you don't need to check, but if you want me to check, I can. So here we go. Check. Cube root is cube root of 6 times my proposed solution, 31 over 3 plus 2, and then minus 4. The question is that going to equal to 0, right? So let's just check. So this is cube root of, okay, 3 goes into 3 once and then into 6 twice. So you got 2 times 31. So what the heck is that? 262, and then plus 2, and then minus 4. So then here you're going to have cube root of 64 minus 4. And the cube root of 64 is 4 minus 4, which is going to equal to 0, which matches up. Okay, so our answer is correct. All right, now let's go to the next one. Subtract, write the result in the form, be careful here, a plus bi. Right? So I want the real part first and then the imaginary part last. Okay? So let's take a look at this. So this is not too bad because all you have to do is just combine. Think of it in combining the like term. So here this is same thing as 23i minus 4. And then all you have to do is just drop that parentheses by distributing that negative sign in. So you're going to have negative 12 and then negative 32i. All right? So then let's combine the real part together. You have negative 4 minus 12, so that's minus 16. And then here you have 23i minus the 32i. So what is that? Minus 9i. So now this is of the form a plus bi, right? So we're good to go. So our answer is going to be negative 16 minus 9i. Okay, moving right along. So the next one, find the product of whole quantity 3 minus I square root of 5 to the second power. Okay, so be careful here. This does not equal to this. This does not equal to 3 squared minus I root 5 squared. This is a no. Okay, this is an illegal mathematics. Okay, so what we need to do is this. This expression is the same thing as 3 minus I root 5. Multiply here by 3 minus the I root 5. So in fact, we're going to have to FOIL. Okay. So let's do it. So this is same thing as 9 and then minus 3 root 5 times the I just rearranged the ordering. I just put the I at the end. And then another minus 3 root 5 times the I. And then now you're going to have plus I root 5 times another I root 5, right? Which is same thing as, I'll just do that on the next step. Okay, so then this is same thing as 9. And then I can combine these two, no? Minus 3 root 5 and then minus another 3 root 5. That's going to give us, what is that? Minus 6 root 5 times the I. Now let's take a look at this. Now here you're going to have I squared times the square root of 5 times the square root of 5, right? So here, remember that I squared. I should change the color on this. I squared is negative 1. Okay, so here, what we need to do is we're going to go 9 minus 6 root 5I. And then remember that root 5 times root 5 is going to give us a 5 back, right? So this is going to be 5. And then this is going to be negative 1. So here altogether, you're going to have negative 5. Make sense? Okay, so now let's combine the real part together. So you have 9 minus 5. So you're going to have 4 minus 6 root 5 times the I. And I think that's going to be our answer. So let me just write 4 minus 6 root 5I. Okay, so the next one is simplify to the form a plus bi. So you're given 4 minus 3i over 2 minus 3i. Now, the trick is this. Multiply top and the bottom by the conjugate of the denominator. Okay, so trick is to multiply top and bottom by the conjugate of the denominator. So in this case, 2 minus 3i, which is 2 plus 3i. That will be the conjugate of 2 minus 3i. Okay, so here what we're going to do is take this and multiply here by 2 plus 3i and then 2 plus 3i. Okay, now what we need to do is we're going to FOIL the top and then we're going to FOIL the bottom. So here you're going to have 8 and then what is that? Plus 12i minus 6i and then minus 9i squared. And then whole thing over. 4 plus 6i minus 6i and then minus 9i squared. Okay, so again, I squared, this is going to be negative 1. Keep that in mind. So now let's take it from here. I'm running out of room. So this is same thing as 8. And then let me just combine that 12i minus 6i, that's plus 6i. And then now you're going to have a minus 9 times negative 1. So this sign's going to become plus 9. So here you're going to have plus 9. Whole thing over. Now for the bottom, 6i and negative 6i is going to cancel each other out. So right now you have 4. And then here you're going to have negative 9 times it by negative 1. So this is going to become positive 9. So here you're going to have plus 9. So combining the real parts together, so what is that? 17 plus 6i all over 13. Okay, so if you want to separate this into 17 over 13 plus 6 over 13i, that's totally fine, but let me just box that for the answer, and here you have it. Okay, so for the last answer, you're going to be asked to simplify the expression I to the 54th. So now, do you remember that cycle here? So you're going to have I, and then I squared, I cubed, and then I to the 4th, and then it's going to repeat. So basically, the I is going to repeat in cycles of 4. So I squared is -1, and then I cubed is nothing but I squared times I, right? So this is just going to be -I, and then I to the 4th is same thing as I squared times another I squared. So that's -1 times -1, so I to the 4th is going to be 1. So your choices are either I or -1, -I, or +1. Keep that in mind, and let's do the problem. So again, it's going to cycle in order of 4. So all you have to do is this, 54, and then you divide this by 4. And then what you want is that remainder. Okay, so let's do it. 4 goes into 5 once. Subtract, you're going to have a 14. And then what goes in? 3. 3 times 4 is 12. So the remainder is 2. Right, so let me just box this. So basically, so therefore, remember the 3 dots means therefore, I to the 54 is exactly the same thing as I to the second power. But what's I to the second power? That's -1. So -1 is going to be our answer. All right, how you all doing? I hope this helped a little bit. And I'm a human, so I do make mistakes all the time. So if I made a mistake somewhere, please let me know. And of course, if you have any questions at all, please let me know. All right, y'all, let's kick some butt on the midterm, and we got this.